So good morning friends. Today I will discuss a very simple reaction, that is decomposition of nitrogen pentoxide. Yesterday or day before yesterday I discussed about the rules, that how to write rate laws on the basis of reaction mechanism. So, and today I will use steady state approximation method. So you know that whenever I would like to write the rate law for a reaction, so first I must write the overall reaction. Like suppose the overall reaction is N2O5 converted into, I think, 4 NO2 and O2. Of course, it is also gas. It is also gas. So, what is my question? Devise. There are two type of things. First is that devise rate law. You know the definition of the rate law, the relationship between the rate constant and the concentration of the things. So basically the rate is minus 2 K1 K2 N2O5 first order with respect K inverse 1 plus K, like that. I'll check it first. Or sometimes, if you know the rate law, so you have to devise a mechanism which is consistent with the rate law. So you follow my point. It is a vice versa type of things. If you know the reaction mechanism or most probable reaction mechanism, then you can devise the rate law on the basis of that mechanism. Or if you know the rate law, so on the basis of rate law, you can figure out the reaction mechanism. Okay. Now I have taken this is a very common example, and if you refer the books of P.W. Atkins, or Ira N. Levine or G.M. Barrow, you will get the mechanism of this reaction. So now the last question, that yes, I ask you that you have to write the mechanism which is consistent with the rate law. Now the question arises, which method you will use? So for this I will use steady state approximation method. Steady state approximation. I will not use the steady state approximation method. Okay. So now question is complete, that devise rate law on the basis of following mechanism using steady state approximation method, right? Now, this is slightly not difficult. I will not say difficult, but is a more than one intermediates are involved. I have already told you this reaction. This is different. C plus M, and then this M react with another reactance is equal to D. So this is different because here is only one intermediate is there. But today, when you gone through this whole reaction mechanism, you will find that there are two intermediates. Number one question. Number two, sometimes you may get confused that if there is more than 2 steps or 4 steps, then which step is rate determining step. That is the objective of this today's presentation. So let me first write the mechanism and then we'll devise the rate law which is consistent with the mechanism. So let me write the first the mechanism. First part is that N2O5 is the first step from NO2 plus NO3. The first step, and this is K1, this is K inverse 1. It is not slow step because generally we assume that when there is a pre-equilibrium, the step must be fast. It is very difficult to monitor the concentration. Okay. Second, this NO2 again react with NO3. It will form NO plus NO2 plus oxygen. So naturally it is K2. Then there are two mechanisms. In one book it is like that, this N2O5 react with NO. It is again K3. So it is, I think, 3NO2. But the thumb rules is that whenever you apply the steady state approximation method, you must write the individual species. You must write individual species. So I should write here not 3NO2 but NO2 plus NO2 plus NO2. You follow my point? Customary, it is not. Now there is another mechanism that sometimes what happens, this NO is react with NO3, it will form 2NO2. But today I will use this mechanism, not this mechanism. But there is a possibility, that means that is also possible. But today I am using this mechanism, so I must erase these things. And then this is the elementary step. So now I will write the complete mechanism. So now, in my previous class I told you the first point is that identify the rate determining step. Identify the rate determining step. As because here the rate determining step, because this is first step, but fortunately our main reactant is N2O5. So if I want to monitor the concentration of this N2O5 in the first step, it would be difficult for me because it is a fast. But fortunately it is also seen in the step number 3. So, and this is of course the slow step. So you can ask me, sir, why not the 2? Because in 2 step number 2, NO is there, which is an intermediate, so it can also react with this thing. So I think this is the rate determining step. So I can write rate determining step. So we have identified the first part, the rate determining step, and write down the rate of formation of N2O5. I will write one by one. Second, you know that identification of the intermediate. Identification of the intermediate. Now, identification of the intermediate, I will use the red color. That when I write overall reaction, I will find this NO and NO, that means 2 N2O5 and 1, 2, 3, 4, 5 like, but one NO2 is, this NO2 will be removed there. So it will get 4 NO and oxygen. But my question is that intermediate. Mediate. So first thing is that here NO3, because it is involved in the first step, in second step it is consumed. So this is intermediate number 1. Second, NO, it is obtained here, but again it is consumed. So there is 2 intermediate. So what is the novelty of this decomposition of nitrogen pentoxide? Here there are 2 intermediates. So while solving the steady state approximation, we have to eliminate both the intermediate. But before that, we have to write the rate of formation of N2O5, because that is the slow step. Whatever rate of change in, not formation, rate of change of concentration of N2O5. So I must write, let me erase these things. Now you focus on this thing. So I am writing the rate determining step. I am writing the rate determining step. Now bear in mind, because that is important. So it is d by dt of N2O5, first point. Although this is my rate determining step, but I am, whenever I want to monitor it, so I have to monitor this also. And here it is, concentration is decreasing. So I must write minus first point. Minus. Okay. So it is K1 N2O5 it is a reversible process. The opposite is formation of N2O5. So you can write plus. So but it is actually K NO2 NO3. And here again it is consumed. So again it must write the minus. It be minus. So K3 N2O5 and NO. So first step is over. That is the rate determining step. So my next step, because now I am applying the steady state approximation, so I have to eliminate the intermediates. This part again read, this part. So for elimination of NO3 and NO, I have to determine the NO3 and NO using steady state approximation method. So first, d by dt of NO3. Very simple. D by dt of NO3. So first here it is formed. So I can write K1 depends upon the N2O5 here is also, so minus K inverse 1 NO2 NO3. Here is also consumed, so minus K2 NO2 and NO3. You must write that applying steady state approximation. Steady state approximation, and we assume that the value of d by dt of NO3 Therefore, it is called the steady state is equal to 0. Is equal to 0. So that means I can write like that: K1 N2O5 is equal to, because I have to determine the value of NO3. So is equal to K inverse 1 NO2 plus. So if I common it, so K inverse 1 NO2 plus K2 NO2. You can write K1 again like that, no problem. So NO3 is equal to, or you can write directly also, as I discussed in my previous classes. That means you can eliminate this N3 and denominator and numerator. That is not a problem. You can directly write these things. But you can write also like that. So K1 N2O5 divided by K1 plus K2 NO2. So I can substitute the value of NO3 there. It is clear, very simple. So now I have to determine the concentration of another intermediate, that is the NO. We have determined one. So this is again, now I must solve the formation of the NO. So I must remove all these things. NO3 is important. So red color is a bracket. Similarly, I will determine the dy/dt of NO. So d by dt of NO, intermediate number 2. Suppose your rate determining step composed of only one intermediate, so you need not to be determine the intermediate number 2. But here you have seen NO3 is also there, NO2 is also there. So therefore we have to determine both NO as well as NO3. If there are 3 intermediates, we have to determine the concentration of 3 intermediates. So let me start again. dy/dt of NO. So first step, there is no NO. Second step, NO is produced. So no negative. So I can write like that. K2 NO2 NO3 K2, because it is formed. Here it is decreasing, so minus K3 N2O5 and NO. So applying the same thing, that the steady state approximation method, so we have to consider that d by dt of NO is equal to 0. So therefore, I can directly write here, or I can write here, NO is equal to K2, this one, NO2, NO3 divided by K3 N2O5. But there is a problem. Problem is that in this NO, again one intermediate is there, and we know the value of this intermediate, so I have to just do one extra step. What is that extra step? I have to substitute the value of NO3 from here, so I can write like that, K2 NO2, like this NO3. In place of NO3, I have to write K1 N2O5. No mathematics is involved, simple thing. So again, you just check it, K2 NO2. In place of NO3, I am writing K1 NO5 divided by K inverse 1 plus K2 NO2 and here is also K3 N2O5. So fortunately we are very happy because everything, this, these, so the value of NO is equal to, again I will use the red color, K1 K2 divided by K3. I think K3 will also somehow, in first case, is there any K3? NO3, no, K3 is not there. It must be some K3 must be there. K3 must be there. Okay, let me check, no problem. So again I can use the red color. So I am getting two values. First NO3 and second is the NO. Second is the NO. So now the last step, we know the rate determining step. We know the value of NO3 and NO. So just simply you have to substitute the value of NO and NO3 in this what main equation. We have to substitute the value of NO and NO3 in our main equation and you will get the final rate law. So let me remove all these things so that we will directly write the final equation. So I can remove from here. Now it is not required. Not required. We don't need this also. We don't need this also. We don't need this also. We need only the value of NO3 and NO, and finally we have to substitute the value of, and as I mentioned in my first thing, that the rate is equal to minus like that 2, whatever it is, K1, K2, maybe I may be wrong, but I need such type of values, right? Whatever it is. This is the rate law finally. So last step is that we have to substitute the value of NO3 and NO in their main equation, and you will get, if you will get this thing, that means whatever the values of rate laws, it is compatible with the mechanism. That is the objective of this decomposition of N2O5. So just nothing, simple. So rate is equal to, last step, keep patient, last step. So minus, mathematics students can solve it in a fraction of a second, but for biology students it will require some more exercise. Otherwise directly you can solve it. Like why? Because K1 N2O5, first line, plus K NO2 is not intermediate, so we can write complete NO2. Then the value of NO3, you know the value of NO3 from here. So K1 N2O5 divided by K1 plus K2 and NO2. Okay, I am just substitute this value in this. So now I don't need this value. I don't need this value. So I have substituted the value of NO3. Minus I have to substitute the value of this NO. So K3 N2O5 I have to substitute the value of NO. So again K1 K2 divided by K3 K inverse 1 plus K2, isn't it? So I don't need this NO here, so this NO can be also. Then a mathematics student can solve it using a fraction, as I told you, that this and this, this and this. So it is like that everywhere. Minus K1 N2O5, we can N2O5 we can take the common, plus K1 K inverse 1 N2O5 minus K1 K2 N2O5, of course divided by K2. So if you take the LCM for mathematics students can solve it like that. Or what you do, you can do one thing, that minus N2O5 is common. Minus N2O5 is common. Okay. So K1, here is also plus, so we need the minus. So K1, K inverse 1 divided by K1 plus K2. Right? Here is also minus, so we have to write the plus. So you can write again same thing, K1, K2, K inverse 1 plus K2. So you just solve it. LCM, you determine the LCM. So what you will get? So K1 and K inverse 1 like that. So it will cancel out all these things. So this K inverse 1, K1, 2 and K1, 2. So you will get the final result is minus 2 because 2, K1 and K2, N2O5 to get the K inverse 1 and K2. So this is the simple derivation of this N2O5 reaction. Thank you.